Starting with number 1, we are simplifying, which means add like terms. So I'm going to look up here, and I've got a negative a to the 4th and a negative 4a to the 4th. Those are like terms. If I add them together, that's negative 5a to the 4th. I started with the a to the 4th because standard form means put the biggest exponent first. Once I'm done with those, you can actually mark them out so you don't accidentally mess with them again. Then I've got 4a and 8a, which add together and get 12a. And then we've got just our numbers. Negative 4 plus 8 is plus 4. That's our answer. That should be pretty easy. Okay, on the next one, same kind of deal. X to the 4th is my biggest exponent, so that gives me negative 3x to the 4th. Then I go to my x squareds and do negative 8x squared plus 6x squared is negative 2x squared. And then negative 8 minus 2 is negative 10. That's my answer. All we're doing is adding like terms. Now on the second set of stuff where we're subtracting, it changes our signs in the second parentheses. So I'm going to change this to a plus, but that means I have to change all of these signs in my second parentheses. And now I add like terms. So p to the 4th would be negative 6p to the 4th plus 5p to the 4th is negative 1p to the 4th. And then we would do just this p cubed is the only one I have, so I'm just going to write it. It doesn't have anything to add with. Then our p squared is negative 5p squared plus 4p squared is negative 1p squared. And then I don't have any p's, and then I have this negative 4 by itself. Okay, I don't have to write those ones in front of p to the 4th or p squared, but you can leave them if you wrote them down. Either way is fine. Also, notice on all of these problems, I didn't have to put in like plus 0p as placeholders. That's only when we're doing a problem like long division or synthetic division, not when we have our answer. So I don't have to write plus 0 something if it's not there. So 4, change all the signs in the second parentheses, so all of those become positives, and add like terms. Negative 8x to the 4th plus 6x to the 4th. Negative 2x to the 4th. And then x squared, 2x squared plus 6x squared is 8x squared. Negative 8 plus 7 is negative 1. So that's my answer. Pretty easy, hopefully. Find each product means on these first two to FOIL. So x times 5x gives us 5x squared. Because when we multiply, we add our exponents together. X times negative y is negative xy. Negative y times 5x is negative 5xy. And then negative y times negative y is plus y squared. Don't get bent out of shape about what's standard form here. Just put it in the order you've got it. So we drop down the 5x squared. Our middle terms are like terms and give us negative 6xy. And then we put the y squared. You don't have to rearrange this and put the y squared in front or whatever. You just leave it like this. This is standard form. So 6 is pretty much the same and should be pretty easy. 49a squared plus 28ab plus 7ab plus 4b squared. Again, don't worry about what order they go in, since we have an a squared and a b squared. In the middle, though, that should be 35ab plus 4b squared. This last one under find each product, number 7, has too many terms in the second parentheses to FOIL, so it's like we're distributing twice. So I do 2n times n squared, and I get 2n cubed. And then I do 2n times 7n and get 14n squared. And then 2n times negative 8 is negative 16n. And there's a way we can do this now to help us. If when I distribute negative 4 and I do negative 4 times n squared, that's negative 4n squared. And if I write it underneath this n squared and start a new line, it's going to be really easy to add like terms. Because then I do negative 4 times 7n is negative 28n. So look, those like terms line up. And then negative 4 times negative 8 is positive 32. Then I add my columns together here. And I get 2n cubed plus 10n squared minus 44n plus 32. You don't have to do it that way. If we had just written it all out next to each other, we would have to look for our like terms. Okay, but that's our answer. The next thing I want to do is over on the side, it says divide using long division, and I was trying to be funny and I put number A, but apparently this was really confusing. So my bad. But I wanted this problem to be on here, and so if you don't have a lot of room right there, 8 through 13 don't take up very much room, so you can kind of do it towards the bottom. But on top, what we're dividing by is not in standard form. So that's the first thing we're going to do is write it in standard form. 3v cubed would go first, and then 28v squared, and then 39v, and then minus 78. That's what we're dividing into. And we're dividing it by 3v plus 10. So, remember how to do long division. We do, what do I multiply 3v by to get 3v cubed? Which would be just v squared. And then I come down here off to the side and I say, well, what happens when I multiply both of them, 3v plus 10, by v squared? And remember, next we multiply by a negative 1. You can do those at the same time. Just multiply by a negative v squared instead of doing this and then multiplying by a negative 1. The important thing to remember is our signs change after we multiply. That's a cubed. Minus 10v squared. That's what goes underneath here. Minus 3v cubed minus 10v squared. Okay, so this cancels, which is what we wanted. 28v squared minus 10v squared is 18v squared. And then I drop down my next number, plus 39v, and I start over. Now, when I do this, if at this point I had something that I couldn't get, like 3v times what gives us 18v squared? 6v, okay? And so if I get to this point and I had something like 20, which I can't do 3 times something and get 20, I know I've messed up somewhere. And most likely it was right here with this, like I put the wrong sign here. Okay, like if I had added instead of subtracted, I'd get 38 and that wouldn't work. So if that happens to you, go back and look for a mistake. But this is plus 6v, so we multiply 6v times 3v plus 10. And I don't want to add it, I want to subtract it, so I'm going to multiply by a negative as well. That gives me negative 18v squared minus 60v so these cancel. 39v minus 60v is negative 21v. And you drop down your next term. And we say, what do I multiply 3v by to get negative 21v? Negative 7. So we do negative 7 times 3v plus 10. But I want to change the sign, so I'm really going to multiply by positive 7, which gives me 21v plus 70. Giving me a remainder here of negative 8. I know it's my remainder because I ran out of stuff up here, right? I've got v squared v and a number, so this has to be my remainder. Minus 8 over what I divided by, 3v plus 10. This is my answer. So if it says use long division, make sure you use long division and don't try to do synthetic division on that. All right, so name each polynomial by degree and number of terms. So you will have to have these memorized, but it will probably be multiple choice. So that means you're like the words will be there. Like you don't necessarily have to have them off the top of your head as long as you know which one goes with which. So by degree, it's squared, so that's a quadratic. And there's one term, which makes it a monomial, because mono means one. So that's what we mean by naming by degree and number of terms. So this is to the fifth power, which is quintic. There's 4 terms. That's too many for us to name it specifically. So it's a polynomial with 4 terms. This has a degree of 1, so it's linear. Or if you can remember, this would look just like a line. And there's 2 terms, so that's binomial. This doesn't have a variable, so it's a constant monomial. This is cubed, so that's cubic. That's handy, it's cubed, cubic, those go together. And then it's a binomial. And to the 4th power, it's like quarters, it's quartic. Wow. Quartic. Trinomial. Okay, so you'll just have to be able to pick out which name is right. Now we're going to use our calculator to find the relative minimums and the relative maximums. Minima is just a plural of minimum, and maxima is a plural of maximum. So you get on your calculator and you type this into y equals so you type in negative x cubed minus 8x squared minus 16x minus 4. You graph it, and if you have a weird window, make sure that you remember that you can zoom standard. Go to the zoom button. Oh, that's too many O's. I'm just going to leave it. Zoom standard gives you a normal window. Okay, so if it doesn't show up at first, zoom standard. And our graph looks kind of like this. Okay, kind of like this, relatively like this. Where is our minimum on this graph? It's down here. And where's our maximum? It's up here. And so when we go through on our calculator and find it, we'll have to do a left bound and a right bound on both of these. Okay. So you go to second trace, find the minimum. So you go all the way over to the left side of the minimum, press enter, go to the right side of the minimum, press enter, go to the middle to guess. And it's going to tell you something that pretty clearly rounds to -4. Like earlier I got -3.999999998, but this time for some reason I have -4.000001. That's -4, comma, -4. Then we do second trace and go to maximum and do the same thing for our maximum. And we should get, because it says round to the nearest tenth, that's 1 decimal place, so -1.3, comma, 5.5. Okay. Hey Creed, will you wake your table up? Or just Ethan, apparently. Okay, yeah, come on Ethan. It's okay, you can keep your head up. Leaning against the board. There you go. There you go. Or yeah, Peyton's shoulder's right there. I promise I won't take a picture if you lean your head on Peyton's shoulder. I promise. Okay, well. Oh, okay. I have it ready now just in case it happens again. Okay, number 15. Plug that one in now. Now, if you're having issues getting this on the calculator, it's really not that hard. And so try to ask me outside of class, like at the end or something, ask somebody, because these should be really easy problems. But if you don't know how to do it, you're probably going to miss it. So my graph this time looks slightly different, but mostly the same. Something like this. So our minimum's over here on, our maximum's over here on the left, our minimum is on the right. So calculate them. Our minimum is 2.7, comma, negative 5.5. And our maximum is 0.4. And on these kind of problems, every now and then the calculator will give you something that looks really weird like this. Okay, if it tells you something e to the negative power, it's giving it to you in scientific notation because it's such a small number, and what they really mean is 0. But the calculator's not as smart as you are, so it thinks it's this number when really we know that this means 0. Because if I wrote that out not in scientific notation, that would be this. Ish. What is that? That's basically 0, right? If we round to a 10th especially, that's 0. So if you get something that looks like this, remember that it's just 0. All right, synthetic division. This was the division that we liked doing because it was shorter. So we started by setting what we're dividing by equal to 0, which meant subtract 8 from both sides and get negative 8. That's the number that goes over in our box. And next to that, we put our coefficients. So we've got 1n cubed plus 2n squared minus 41n plus 57. And then we work this out. So we take the first number and we drop it. And then we multiply. And this goes in a pattern back and forth. So negative 8 times 1 is negative 8. Add 2 plus negative 8 is negative 6. Now we multiply. Negative 8 times negative 6 is 48. Then we add. Negative 41 plus 48 is 7. Negative 8 times 7 is negative 56. And 57 minus 56 is 1. Now we write our answer. We started with n cubed, which means our answer is 1 degree less, which is n squared. So 1n squared minus 6n plus 7. Our last number will always be our remainder, so we put 1 over what we divided by, which was n plus 8. And if our remainder is 0, we don't have to write anything there at the end. So on 17, set this equal to 0 and solve. So subtract 3 and get x equals negative 3. When we write out our coefficients, though, we have to be careful. We've got 1x cubed plus 3x squared plus, oh no, where is my x? There's not one, so I have to put a 0 in that spot. And then I put the 5. So when I do my synthetic division, I drop the 1. Negative 3 times 1 is negative 3. 3 plus negative 3 is 0. We got to be careful here because sometimes we can get carried away with zeros. Negative 3 times 0 is 0. 0 plus 0 is 0. Negative 3 times 0 is 0. And 5 plus 0 is 5, not 0. So our answer is 1x squared plus 0x plus 0 plus our remainder 5 over x plus 3. But we don't really need the 0x and the 0, so it's really x squared plus 5 over x plus 3. So either write it out this first way and then realize those zeros don't need to be there, or just remember the last number was our remainder, so that's why we had to put it over x plus 3. We wouldn't put x squared plus 5. We have to leave it as our remainder. 18, is when we did the very first type of division problem, and we said take everything that's on top and put it over what's on bottom, like this. You can do long division on this, but I feel like that makes it harder. So if it just says divide, this is what it means. And then we simplify each of these fractions, because we can do things like 50 divided by 10, well, that's 5. And the a cubed, since they're the same, cancel out. Again, on the second term, 50 divided by 10 is 5, but this time my a's don't completely cancel out. I subtract my exponents and get 1, but there's more a's on the bottom, so I have to put a on the bottom. You can think of it like this. A squared is a times a cubed is a times a, so I can cancel out 2 of them, which leaves an a on the bottom. For real. And then 5 over 10, I can divide both of those by 5 and get 1 over 2. Now I have 2 more a's on bottom than on top, so that becomes a squared on the bottom. So we have to put 1 over 2a squared, because the 2 is on the bottom and the a squared's on the bottom. There was nothing left on top, so we put a 1. And that's my answer. So on this one, I think this one's easier, because we don't end up with any x's on the bottom. And if you can skip this step where you write it out, that's fine. Like if you can just look at each of them, that's fine. This should be 2 over 10 is 1/5. And we have 3 minus 1 for our exponent, so that's an x squared on top. So I can also write that without the 1 in front, and it would just be x squared over 5, or I could write 1/5 x squared. 40 divided by 10 is 4. And x squared over x gives us x, so that one doesn't end up with a fraction, because there would be like a 1 on bottom, which we don't need. 2 over 10 is 1/5, and the x's cancel each other out, so that's just plus 1/5. Now, until we get to the last page, the rest of this stuff is from chapter 5, because remember, we replace your test. If you get higher on this one, it replaces your previous test, so that's why you're seeing things from chapter 5. So it tells me to find zeros by factoring. To factor this, I need to slide and divide, or use the boxes if you prefer. So I slide the 5 to the -3 and get -15. And then I factor into 2 parentheses. Remember, the way we factor is we say, what do I multiply together to get the last number that will add together to give me the middle number? So my only choices for 15 are 1 and 15 and 3 and 5. Which of those, if I add them together and one of them is negative, can I get -2? Yeah, -5 times 3. So -5 and +3. But we're not done. We slid, so we've got to divide, because this is slide and divide. We slid the 5 earlier, that's what we divide by here. 5 over 5 simplifies to -1, x minus 1. And then this doesn't simplify, so we move the 5 in front. But it asks us for the zeros, which means we have to set this equal to 0 and solve. And you want to be careful here, because let's say that this is a multiple choice question. The answer to this first part, x minus 1 equals 0, is not -1. We have to add 1 to both sides, and we get +1. But you know what? -1 will probably be an answer choice, just to confuse you. Okay, so don't stop where it's factored. Keep going and find your zeros. So for 5x plus 3 equals 0, I have to subtract 3 and then divide by 5. So x equals -3/5 is my second answer. Anytime we have an x squared at the beginning, we should be getting two answers like this. One of our answers is 1, and one of our answers is negative 3/5. So on 21, slide. Well, let's forget that happened. Slide the 3 to the negative 10, so that's x squared minus x minus 30. Factor. And say, what do I multiply together to get negative 30 that adds to get negative 1? Well, it's got to be two numbers that are really close together, like 6 and 5. So we want the 6 to be negative to get a negative 1. Divide by the 3 that we moved earlier. So this simplifies to x minus 2. This one, we move the 3 in front. This one almost looks like our previous problem, but the numbers are backwards here from what we did. We had 5x plus 3, but this is 3x plus 5. And set it equal to 0 and solve. So x minus 2 equals 0. I add 2 to both sides and get x equals positive 2. 3x plus 5 equals 0. I subtract 5. And then I divide by 3. And I get x equals negative 5/3. And x equals 2 was my other answer. On the next page, we've got i's. Remember that we treat i's a lot like we do x's, except when we get I squared, we change it to negative 1. So I'm adding, which means I just add like terms. 4 plus 4 is 8. 8i plus 4i is 12i. Notice that's not 12i squared, it's just 12i, because when we add things together, we don't change our variable. If you want to call I a variable in this case, kind of is. 23, we're multiplying, so we're going to FOIL. So first, negative 4 times 2 is negative 8. Outer, negative 4 times 4i is negative 16i. Inner, 6i times 2 is 12i. Last, 6i times 4i is plus 24i squared. So we take the I squared and we change it to a negative 1, which means I really have 24 times negative 1, which is a negative 24. And so when I add my like terms, I do negative 8 plus a negative 24, which is negative 32. Negative 16i plus 12i is negative 4i. And just so you know, we write the I second. That's standard form. So you wouldn't like rearrange that and put the i's first. They go second. 24. Remember, the negative inside means I get an I on the outside. To simplify the square root, we do a factor tree. Now, 2/16 is a really big number, but it's even, so I know it's divisible by 2. And if I divide it by 2, I get 108. Like, do that on your calculator if you don't know. 2/16 divided by 2 is 108. 108 is still pretty big, although you might know that it's 9 times 12. But if not, just do 2 again. 2 times 54. And at this point, we should definitely know that this is 9 and 6. But we could do 2 again if we wanted to. 9 is 3 and 3. 6 is 2 and 3. We just look at the end of our tree, at the leaves, and we look for pairs of numbers. We have a pair of 2s, and we have a pair of 3s. And those both go on the outside with the I. And on the inside, we put our numbers that are left over, which we have a 2 and a 3. So that means I have 6i square roots of 6. $25, we know there's going to be an I on the outside because of the negative. When I do the factor tree for this, again, it's a big number, so I'm going to divide it by 2. and I get 144. Hey, what times what gives you 144? 12 times 12. I'm going to show you a secret to the factor tree. If you end up with two numbers that are the same like this, we can stop and say, hey, I have a pair of 12s, so this is 12 on the outside. My number left over is 2 on the inside. This is 12i square root of 2. You're allowed to do that. If you get something that you know breaks up into two things that are the same, you can stop there and pull it to the outside. Now, if I had kept going because I didn't realize that, I would still get the same thing because I'd have 2 pairs of 2s and a pair of 3s. So we still get 12 on the outside. All right, 26. All we're trying to do here is get the I off the bottom. And so to do that, I just need to times the top and the bottom by I. So on top, that means distributing negative 1i minus 8i squared. On the bottom, that just gives us 10i squared. And then we take our I squareds and change them to negative 1s.
Wait, why do you multiply it by I and not?
You can multiply it by 10i. And if you multiply it by 10i, you're going to end up with numbers at the end that are bigger than what we're going to end up with, which means you can divide everything by 10 to simplify. So if you want to multiply by 10i, it still works. You just have to simplify at the end. So this is on top negative I plus 8, and on bottom negative 10. But as some of us found out on the last test, this would not probably be an answer choice for multiple choice because the test generator doesn't like negatives on the bottom. So we'd change all of the signs, and I'm also going to rearrange this. This would be negative 8 plus I over positive 10. So if it was free response, I would take negative I plus 8 over negative 10. That would be fine. But if it's multiple choice and you're trying to pick out the right answer, try changing all the signs if you don't see what your answer is. Or try seeing if everything divides by like 2 or 3 or something, or 10. When I have two terms on bottom, like on 27, it's harder to get the I off the bottom. I have to take what's on the bottom and change the sign, and that's what I multiply by, 9 plus 2i. Which means I have to FOIL on the top and the bottom. The whole reason this works is when I do 9 minus 2i times 9 plus 2i, my middle terms will cancel out when I FOIL, which gets rid of my i's. So on top, I get 72 plus 16i plus 81i plus 18i squared. And on bottom, I get 81 plus 18i minus 18i minus 4i squared. So I changed my I squareds to negative 1s and add like terms. 72 minus 18, because of that negative 1, is 54. 16i plus 81i is 97i. On bottom, the i's go away. And 81, this isn't going to be minus 4, it's going to be plus 4 now. So 81 plus 4 is 85. If I could divide all of these numbers by something, that's what I would do. Like if all of them were divisible by 3, I'd go for it and divide them all by 3. But since that doesn't happen, this is our answer. Okay, 28. When I solve by taking square roots, all I'm doing is trying to get k squared by itself. So I add 8 to both sides. and get 2k squared equals 34. I divide by 2 and get k squared equals 17. So I square root both sides, and here's the tricky part. When I square root in an equation, I have to put a plus or minus, and the square root of 17 doesn't simplify, so I just leave it as the square root of 17. Which answer choice is correct? B. Not C, because C only has the positive answer. Anytime we have k squared or x squared or whatever, it should give you two answers. And then don't forget to actually have the square root. That's why we wouldn't pick D. And A would just be a really silly choice. I don't know why we would pick A, unless we just were trying to be silly. I like being silly too, but I mean, it's whatever. Not for math tests. 29, quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, to do this, I need a, b, and c, and this is not written right. I need to get everything on one side, so I'm going to add 11k over to the left side and write it in standard form, which means the 11k goes in the middle. And only once I have it written like this can I say a is 5, b is 11, and c is 6. If you leave the 11k over on the right side, you're probably not going to do this right. Yeah, you're going to have a bad time. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. This one actually simplifies pretty nicely. If you do 11 squared minus 4 times 5 times 6, you get 1. The square root of 1 is 1. So instead of writing square root of 1, I'm just going to write 1. And 2 times 5 on the bottom gives us 10. So what we want is to split this up into a negative 11 plus 1 over 10 and negative 11 minus 1 over 10. And we want to figure out what those two numbers are. So the first one, negative 11 plus 1 is negative 10. Negative 10 over 10 is negative 1. This one, negative 11 plus a negative 1 is negative 12 over 10, which simplifies to be negative 6 over 5. So negative 6 over 5 and negative 1 are our answers. The path of a kicked soccer ball can be modeled by the function f of x equals 26 plus 2x minus x squared, where x is the horizontal distance in meters and f of x is the height in meters. Find the height of the soccer ball when it has traveled a distance of 4 meters. So 4 would be x, and we're trying to find the height, which is f of x. So all we really need to do on this problem is plug in a 4 for x and figure out what that is. 26 plus 8 minus 16. So I think you get 18. And our units are in meters. But keep in mind, we did a lot of like yesterday-ish, did problems where we graphed it. Like this graph, if you graph it, is a parabola. And there are other things we can tell from this graph that they didn't ask us, like we could have figured out how high up the soccer ball goes by finding the maximum. We could figure out how far it goes before it hits the ground. That would be our 0. So it might be helpful to graph this and see what's happening, or it might just ask us to do this where it told us what x should be and we wanted f of x. That would be the easiest thing for it to ask us. 31 was on our last test. A circuit has a current of 7 plus 2I amps, and another circuit has a current of 1 minus 10I amps. What is the difference between the currents? Well, difference means to subtract. So when I subtract, I change all of my signs. So this becomes plus, this becomes minus, this becomes plus. Then I add like terms. 7 plus negative 1 is 6. 2I plus 10I is 12I. Notice I didn't FOIL because I wasn't multiplying. You only FOIL when you're multiplying, not when you're adding or subtracting. And finally, give the name of the function type and state its degree. State whether the leading coefficient is positive or negative. So for the degree, you need to look at something like how many times it turns. Like this turns 2 times, which makes it a degree of 3, because it's always one more than how many times it turns. So third degree is cubic. That's the name. Then is this a positive or a negative leading coefficient? Positive. Okay, because you can kind of think of it if you connect where it ends to where on that side to that side. What kind of slope is that? It's positive. If it's a positive slope, then it's a positive leading coefficient. 33, it turns 3 times, which means our degree is 4, which is quartic. When they're going the same way, since it's opening up, that's a positive leading coefficient. I'm abbreviating positive. I'm not trying to say something else here. Okay, just in case you guys were confused. Positive. Okay, 34 is just a line, so that's first degree and linear. There are no terms, so 1 more than 0 is 1. And is this a positive or a negative slope? Negative, so it's a negative leading coefficient. This is a parabola, which has a degree of 2, or there's 1 turn, so it's 1 more than 2, which is quadratic. And then since it opens down, that's a negative leading coefficient.